Okay, this lesson is on how to assign oxidation numbers to uh, covalent compounds and also to polyatomic ions. Okay, so all the elements that are found in there. In a previous lesson, I showed you how to determine the oxidation numbers um, on elements and metals mainly in ionic compounds. This one's going to go a little deeper because here we're going to look at every single element, even if it's part of a polyatomic ion. Okay? And these guys don't have charges, so we can't figure out its actual oxidation numbers. There's a couple little rules. Okay, so the first one is that a compound, these two right here, carbon monoxide and carbon dioxide, must have an oxidation number total for everything of 0. Okay, polyatomic ions a little different. Their total is whatever their overall charge is, and in this case, sulfate, the total is not going to be 0, it's going to be 2 minus. Okay, a couple other things that make it helpful. First, I'll just write these down. First and second column compounds, they're whatever their natural charge is. Okay, so the alkali metals always 1 plus. The alkaline earth metals always 2 plus, second column. Okay, um, but here's two other ones. So hydrogen, pretty much always, especially in these examples, it's going to be 1 plus. Okay, uh, as long as it's part of a compound. Check I'm doing this right. Okay, 1 plus. And then oxygen, almost always. There are a couple of exceptions, but basically in everything that we're going to look at, oxygen in a compound will have an oxidation number of 2 minus. Okay, and just before we get going, let's give you an idea. O2, it's going to have an oxidation number of 0 because this is an element. It is not a compound. Okay, it's only when we get into the compound that we have these different oxidation numbers. So the simplest thing to do, and I like doing a little chart because it helps me organize my thinking. So here's my chart. Okay, I put little boxes here for every single atom. The top row is each atom, and the bottom row is the total. So there's a reason why I use all of these. Okay, so what do we got here? So oxygen, if each of them have an oxidation number of 2 minus, and there's 2 atoms, so the total oxidation number would be 4 minus. So that's a total of 0. Okay. We don't have a total of 0 yet because we don't know what the oxidation number is on the carbon. So to get 0, this must be 4 plus. Okay? This one's easy because there's only one atom, so each atom, because there's only one, oxidation number of 4 plus. So carbon's got an oxidation number of 4 plus, oxygen 2 minus. So with the number of atoms there, the total would be 4 minus. Okay? But these ones are the ones that we're really interested in. Okay? I'm going to skip down here to carbon monoxide. So same deal. 2 minus. This is each. And this is total. 2 plus. Okay, because they got a match. And there's only one atom. 2 plus. Okay. So in this compound, carbon has an oxidation number of 2 plus, oxygen 2 minus. So you can see that carbon can have a couple different oxidation states. And that's what we see with a lot of nonmetals. They can have a lot of different oxidation states if they're in covalent compounds. Just of interest, this is the maximum oxidation state. So this compound could actually lose 2 more electrons. So this is why this guy, carbon monoxide, is still relatively reactive, and it's a poison. So if you breathe it in, it's going to react with your um, hemoglobin. So let's take a look at this guy, which is the sulfate molecule. We'll do the exact same thing. Do a chart, each, total, 2 minus here. There's 4 of those. That's a total of 8 minus. Okay, in terms of the electrons, but I only want a total of 2 minus. So how do we get that? The way we get that is we can match up 6 of the charges and leave 2 negatives left over, and there's only 1 atom of sulfur. So its oxidation number is 6 plus. Okay, so sulfur 6 plus, oxygen 2 minus. These are just the totals, they're not the important part. Let me give you one more example just to see what happens when we know the oxidation number. Uh, we determine it, but we have a couple extra atoms. So what do we do with that? Okay, so oxygen, same idea. Total is going to be 2 minus, okay, because of the charge here. Oxygen has an oxidation state of 2 minus. There's 3 of them, 6 minus. How are we going to match that out? Well, if we match up 4 of them and leave 2 negatives, and we get a 2 plus. Now here's the difference, okay? In all these other examples, we only have 1 atom, so it's very simple to figure out what its oxidation number. Here we have 2, okay? So what we're doing here is we're actually calculating an average oxidation number for each of the sulfur atoms, okay? So there's 2 of those, and there's 4 pluses. How's that going to work? Each one should have an oxidation number of 2 plus. And if you did a little bit more detailed uh, analysis, you'd actually figure out from the compound that the 2 sulfur atoms, the way they are positioned, actually have different oxidation numbers. And this is just the average of those 2. Okay, but we're not going to get into that right now. Okay, thank you. This concludes the video lesson.